Hi, I'm Rich with InsideHPC. We're here at SC12 in Salt Lake City. We're here at the Asetek booth, and I'm here with André, the CEO of the company. André, let's start at the beginning. Who is Asetek, and who do you help?
So Asetek is a liquid cooling company. It's all we do, and our main business right now is actually providing desktop PCs, commercial workstations, the software liquid cooling for the CPUs. And the reason we're here at the show is we're actually making a major move towards data center energy efficiency and stuff like that. So to answer your question directly, the people we answer right now are people who like to save money on their energy bill and become a greener data center.
So it's all about energy efficiency, especially in this market where density keeps increasing, more cores. What are we looking at here, André? We got a full rack.
Yeah, so this is actually a bigger size rack than normal. This is a 48U rack. And we actually have 92 nodes with 235 watt processors in each. So when you add it all up, you actually have 40 kilowatts of power here. It's a pretty powerful rack, and probably the most dense and powerful rack you can buy today. And the unusual thing about this rack is, although we put in, let's say, 40 kilowatt of power, we spend something like 300 watts of cooling it. That's it. Where in a normal data center, out of 40 kilowatt, you would perhaps add another 15 kilowatts just for the cooling alone.
So we got this full rack, 37 kilo. That's a pretty serious. I mean, that's probably the capacity of most racks, and you're removing the heat through a closed circuit water system. Is that correct?
No, it's actually a hot water system. And the reason why I emphasize that is that if it was cold water or chilled water, you would need to spend power on actually chilling the water. What we're doing here, and as you can see up here, we have something called a dry cooler, which is essentially a passive radiator like in front of your car with a slow running fan. And then we run liquid through each and every server, and then through our system and up on the roof of, let's say, the building of your data center. And then you use free ambient air to cool your data center.
So what are the advantages of that? Besides, you said you're taking less energy to cool system. Are there any other advantages?
Yes, the other advantage is the fact that we can stand here and talk, have a conversation with a 40 kilowatt rack is actually pretty impressive in itself.
Be blowing my hair
yes.
This way, right? Yeah.
And then there's the density, which obviously for high performance computing is key. So there's no limitation. You could have rack after rack after rack with the most powerful server you can buy for money and still be able to do it. And you don't have to worry about crack or air conditioning or airflow or anything like that.
Well, yeah, I'd love to see some of the components inside. Can you show us that?
Absolutely.
Let's go do that. So André, what are we looking at here?
So if we start from the bottom, this is one of the nodes, also called a server, that I referred to before. There's like 92 of these. There are 2 Intel Xeon processors here. There's a lot of memory in each bank. And on each CPU, we then have a cold plate and a pump. And between the memory DIMMs, we also have coolers. All that heat we pump around out of the server through one of these tubes we have here with dripless quick connects. There's actually fluid inside this tube now. That connects into a rack CDU that you see behind you. And that rack CDU then transports the liquid out of the system into the facilities water or up onto your dry cooler. So you have 92 of these. And to kind of demonstrate how this works, we put in a CFD application, computational fluid dynamics application, that in this case is actually simulating a Formula car. And we are running 90 parallel of these. And that's what this picture shows, that every node in the system is actually stressed 100%. And if you then move over here to our software surveillance system that we have on each our products, you can actually see the water temperature coming in, the water temperature coming out. You can see liquid levels, you can see pressures. And most interesting, what you can see here right now, we're actually removing 37 kilowatts of CPU and memory power.
So, okay, so and is this a server blade, or what do we have here?
This is a 1U server. This is a Cisco 220 server, also equipped with our liquid cooling.
Okay.
And something we haven't talked about is the actual energy savings that you do on your power bill. But what we also have here is actually a small power plant, in the sense that there's so much waste heat from these servers. You can actually recapture that and use it for example, building heating. And as you can see over here, we actually have a hot tub. And this hot top is actually heated by these servers here, and the temperature in that right now is probably 110 degrees. So that's also to illustrate, not only do you save money on cooling, but you can also reuse the heat and save money in that way.
So you could heat your building with the waste heat that you're removing from the computers.
Exactly.
So I got to ask you, Andre, you know, this is the world's fastest computers, the national labs. What kind of reaction are you getting from those guys that really are challenged by this kind of stuff?
Well, actually, we have gotten really good feedback to this whole deal. This is our first entrance into this market. It's the first time on this show, and it's been really positive, both from end users, but also from, you know, the system integrators and the server OEMs.